Yes, hello, good morning. As you have noticed, in contrast to the program, I'm not a manual, but I'm working with RIOT for the last 5 years, so I think I can say just some things about it, and I try to keep myself short. Before I dig into the technical details of RIOT, I'll first give a brief look at what we see for the Internet of Things. So we think of the Internet of Things as a collision of 3 big domains. So wireless connectivity, the Internet, and all these nice, cheap, little energy-efficient devices. And when they came together, bang, we have the Internet of Things. And what this enables us is a whole new world of interconnected devices, which enables us for a whole new world of applications, actually. So there's going to be a lot of new stuff on the application layer. And there's going to be a new world of ways how we interact with the Internet. So it's not going to be you sitting in front of your computer and typing on your keyboard only and reading from screen. But there will be devices connected everywhere to the Internet, and you will have completely new ways of interacting with them, and they will be smart in a way that, I don't know, they do things for you because they know that you want to do them. And so if you look at what's currently already there on the Internet, we have all like computers and laptops and tablets, smartphones, things like Raspberry Pi. And what they have in common, they have all plenty of memory. So we have gigabytes of RAM on these machines. And if you now connect all these new small things to the Internet, you can see that they are at least 2 magnitudes less memory. And I mean, that's probably not gonna change. I mean, these devices will become much smaller and much cheaper and much more energy efficient, but most likely they won't have more memory, more CPU power, more CPU features in the future. So we have to live somehow with these constraints. And the good thing about IoT from the hardware side, it's already there. I mean, there are new devices popping up every day, and there's really a lot of amazing cheap hardware already available. It's very energy efficient, and with a lot of different radio technologies, based on a lot of different microcontrollers, 8-bit, 16-bit, 32-bit platforms. I mean, nowadays it's mostly ARM microcontrollers with its 32-bit architecture, but there's still a lot of Atmel chips or 8-bit architecture out there. A couple of years ago, long before Apple came up with his smartwatch, TI launched this nice Easy 430 Chronos watch, which has a microcontroller on board with a system on chips that communicates in the sub-gigahertz band. I mean, most of you probably know Arduino boards, which make Atmel AVR quite popular for hobbyists and makers. And yeah, it's one example for ARM board. Chosen here the SAM R21 from Atmel, which we're also going to use for our tutorial tomorrow. And yes, so we are still not there with the vision of smart dust that was first mentioned, I think, 15 years ago. But we're getting close to it, and I think it's just a question of some years where we'll have really super small devices that can be deployed everywhere and run for years with battery power or some other constrained energy resources. And the problem is, from the software, we are still not quite there. And if you think like 10 years ago, what you could do with your cell phone, it was not too much. So there were some applications, but most of them were not very usable. And that was not only because the hardware was not the hardware in the cell phones was not powerful enough, but mostly because it was pretty pain in the ass to develop an application for a cell phone. So every application developer had mostly start from scratch, and things just changed when iOS and Android came into the game and provided a unified API and an SDK. And we think that something like a de facto standard API is also necessary to really enable nice software development, nice IoT application development here. And so I'm not saying that we need something like an I don't know, app store or one vendor provides all solution. Definitely not. Just the contrary. But I think we need some kind of a de facto standard for an operating system and an API, so that's get really easy for all developers to implement IoT devices. And the problem is, if you look again at the IoT, so for all these internet hosts, we already have nice operating systems like Linux, BSD, macOS, Windows, Android. I mean, even on the Raspberry Pi, you can just easily run Linux. But all these operating systems just won't work on these small devices. So the obvious solution for us is to run RIOT on these devices. And so let's look again at what's needed for an operating system in the IoT. So what do we want for an operating system? So as we've seen, there's a lot of different devices with different microcontrollers, a wide range of different hardware resources, different memory constraints, and so on, different radio technologies. So an operating system for the IoT definitely needs to support a wide range of hardware architectures. And as we've also seen, the operating system needs to support these low memory devices, and that means that the operating system itself needs to consume little memory, but also provide very efficient, memory-efficient data structures and memory-efficient methods to the application layer. And of course, we want to connect all these devices to the internet. So there is a strong focus to implement interoperable protocols and standards. And we want application developers to develop their application once and then just port it to all the different devices. I mean, of course, there will be still memory constraints and hardware constraints. So you won't just be able to run any application on any device. But I mean, that's something that you cannot abstract from the software perspective. But as long as it is feasible from the hardware side, it should be easy to, or it should be no additional effort to program your application once and flash it to different devices, if it's an Arduino or SAM R21 or whatever. And yes, as I said, we want to make every developer out there able to develop an IoT application, even if we don't know much about all the IETF protocols, or if he doesn't know anything about microcontroller programming. So he just needs to, if he knows how to program a regular PC, he should just be capable of starting an IoT application right away. So just by using standard programming languages and standard programming techniques, as you know it from Linux programming. That also means that we need standard APIs like POSIX. I mean, POSIX sockets are a pretty nice way to implement network protocols. So why not just use them again for IoT devices? And I mean, of course, debugging in this field is very, very important. So there are a lot of good debugging tools already out there. So they just should be just usable from the operating system perspective as well. And yeah, I mean, for every software, comprehensive documentation is crucial. So we all know that. And a lot of people worrying about security and privacy in the IoT, and I think it's very important, and it's very important to worry about it. And we think that the best way to care about these concerns is to make everything as open as possible, use open standards and use open source software, and be independent from any cloud service or independent from any hardware architecture or other technology, independent from a specific vendor. So make everything open source, so then you can have just the rest of the open world, source world looking at the code and identifying potential security issues. And yeah, let's look at how we try to tackle these challenges with RIOT. So obviously, RIOT is open source project, and it's licensed under LGPL, which makes it possible for companies to build their application or maybe even close source drivers on top of RIOT, but RIOT itself's operating system with all its features will stay open source. And it's completely written in ANSI C, plus some minor parts in the really hardware-dependent code that's written in assembler, but the operating system, the kernel itself, it's full written in ANSI C. And it's also possible to plug in your C++ libraries or applications on top of this. We try to support as many useful POSIX features as possible, like all this stuff that's mostly used in applications like pthreads and sockets, to make an compatibility layer on top of it. And one really nice feature is also the RIOT native port, which makes it possible to run your RIOT application direct on your Linux PC, so that you can start right away evaluating and running some experiments on your PC without the need for real IoT hardware, which is very helpful for debugging and testing your applications, even your network code. And of course, you can use all the well-known open source tools for analyzing and debugging, like Wireshark and Wargrind, GDB, GCC, like all these big open source suite that everybody that ever developed anything probably knows. And looking a bit more on the technical specifications of the RIOT kernel, it's a microkernel, which makes it pretty robust against failing drivers and so on, and it makes it also fairly small. So the kernel itself just consumes, I don't know, currently 1.5K of RAM on a 32-bit platform. It depends a little bit on the tool chain and on the specific architecture. But in general, the kernel itself, it's very minimalistic, like a microkernel always is. And it runs on a tickler scheduler. That means that there are no periodic events happening, so that there's nothing that unnecessarily wakes up the device every so and so often. But if there's nothing to do, the device will just sleep until the next interrupt occur. It makes it pretty energy efficient. All the functions in the kernel are based on fixed size data structures and have a deterministic runtime to achieve real-time capabilities, which is also very important for a couple of IoT applications. Yeah, we try to make the interrupt handling as efficient as possible. So whenever we port to a platform, we really focus on implementing the interrupt handling as efficient as possible to have almost zero latency interrupt handling. The whole design of the operating system is very modular, so that if you build your own application on RIOT, you can just pick like the different modules and make it very particular or adapt it to the very particular needs of your application, so that you don't need to link in some modules that you're not going to use to make it as small as possible. And it's built on a regular preemptive multi-threading architecture with a very powerful and nice to program IPC. So yeah, as I said, I'm working with RIOT for the last 5 years, and I find it really very nice to write applications for it. So let's focus on two important things for an operating system for the IoT, which is connectivity and the portability. So for the connectivity, we think that there's not one solution that will fit all scenarios and all use cases. So it's very important to make your network stack configurable and even provide different network stacks, because one just won't fit for all your needs. So we implemented a network stack with all the protocols coming from IETF, 6LoWPAN, QoP, Ripple, and so on, which are basically mostly adaptation of a typical IPv6 network stack adapted to these constrained devices. Additionally, we provide a network stack. We ported CCN Lite, which is implements information-centric networking paradigm. We don't focus on hosts in the network, but on the content, which is and has some in-network caching capabilities, which makes it very interesting for certain type of applications. And It's also possible to use OpenWSN network stack as part of RIOT, so the whole 6-tish and 802.15.4e deterministic MAC layer. And that's another thing we try to do as much as possible, not reinventing the wheel, but make use of code that's already existing, like with OpenWSN or different co-op implementations or crypto libraries that you can just, like, maybe from BSD in the port system, you can just pull code from already upstream repositories and build them on top of RIOT without change anything in the library itself, apart from maybe some patches to the makefile to adapt it. But that's all done by the RIOT build system already. Yeah, so there's a bunch of network protocols already implemented, and there's a lot of work ongoing with Bluetooth Low Energy and lightweight M2N and stuff like this, and some routing protocols. And yeah, we'll probably skip other brief over this. So that's just the design of our native network stack in RIOT, where we kept this as modular as possible again, so that you can easily exchange the protocols at all the different layers. And the idea is to have a unified API between all the layers, so that it's really easy to replace any protocol at any layer, and that you can just stack your protocols together as you like or as you need. And yeah, the other important thing for an IoT operating system is the portability. So as we've seen, there's a huge bunch of new hardware already out there, and new hardware is coming in every day. So it needs to be really easy to port it to a new platform. And that's why we implemented a pretty well-defined hardware abstraction layer. And I mean, currently there's mostly ARM Cortex-M platforms from ARM0 ranging to M4 mostly, which is all these nice energy efficient devices that are not capable of running Linux, but still are powerful enough to do pretty amazing stuff with it. And the good thing about ARM Cortex-M is, like, once you have ported to this architecture, it's dependent on the vendor. It's sometimes only a matter of hours to port RIOT to a new device. So yeah, that's what I just explained. So there's a huge part in RIOT, which is on the left side, the green part, which is completely hardware independent. So you don't need to touch this in order to port it to a new platform. You just need to care about the lower, the hardware, the red part, the hardware abstraction layer. And there again, there are some parts that you don't need to touch if you just go from one Cortex M3 to another. There are even parts that you don't need to touch if you go from M0 to M3. But there are obviously some parts that are just board specific, but that's mostly just configuration. Just say if your, I don't know, ADC is connected to pin 1 or 7 or whatever. So that's really minimized to the max to minimize this porting effort. And yeah, so what can I use RIOT for? Certain use cases, and one will be demonstrated tomorrow by us in the tutorials. So there are some nice students from HAW in Hamburg who did some cool project with RIOT to help you watering plants in your office. Because I mean, probably most know this problem that you will either forget to water your plants, or once you do it, you will do it three times in a row, and so plants in an office often doesn't look happy. And yeah, we will. Lotte and Lucas will present an application based on RIOT how to improve the situation by connecting your plants to the internet. Yeah, so I mean, that is just one use case where you could think of nice new ideas how to connect everyday devices, everyday things to the internet. Of course, there are a lot of commercial and industrial use cases. So there are several companies out there building software on top of RIOT. As we already heard, it's also possible to run RIOT on the IoT Lab, which is really helpful to run your experiments and to debug and evaluate your I don't know, network protocols, routing protocols, and so on. And it's really super easy to run experiments on the IoT lab with RIOT. So it's just a bunch of command lines, bunch of commands or clicks on a web page, and you can just run hundreds of nodes with RIOT and your network protocols. As I also mentioned before, there's the possibility to run a RIOT network just on your Linux PC with some virtualized versions of RIOT applications. So you can actually have a kind of RIOT cluster on your laptop. And apart from, you can also connect these virtual devices with real devices. And yeah, apart from experimental research and commercial use, you can RIOT. It's also very interesting for a lot of hobbyists and makers to build like small things on RIOT. And of course, it's interesting for research and teaching. And yeah, so just to wrap up what I just told you, the main idea for RIOT was really to make an application environment for developers to make software development for the IoT as easy and as fast as possible. So that if you have a nice idea of an IoT application, you can develop it really quick with the help of RIOT. Design it in a way that it's using standard protocols and standard APIs as much as possible, so that you can reuse a lot of code and that you can just run it on your PC for debugging with all the set of well-known tools. And yeah, have it as modular as possible that you can really fit it to your particular needs. And yeah, just a quick look on the history of RIOT, which evolved 2008 as a project for wireless sensor networks, and then 2 years later we started to work on the ITF protocols, and in 2013 we published it on GitHub and started spreading the word, just as I do today. Yeah, that's just showing from Open Hub statistics that the spreading the word helps, and the RIOT community is growing a lot. So currently there are 250 forks approximately on GitHub, and 260 people on the developer mailing list, which is really active. They are located all around the world, and RIOT is also mentoring Google Summer of Code project this year. There's also an IRC channel and a Twitter channel. So if you're interested in knowing more about RIOT, just subscribe to the mailing list or follow us on Twitter, or just come to our tutorial tomorrow. There's also a lot of other events around RIOT. I mean, like just as we do today here on exhibitions, or the bi-weekly video conferencing meetings. So there's a lot of ways to get in contact with us. And yeah, if you're interested to build your own RIOT application, you're invited, and we would be glad to welcome you tomorrow at our tutorial. I don't know if the web page is there yet. So you can go to this URL to see how to prepare yourself for the workshop. And yeah, we would be glad to see you there tomorrow. Any questions?
Okay, I'm developing Mac protocols, in fact, and with Contiki I was using Kuja, and I was wondering what was the state of progress, in fact, of doing the same thing, then having an instruction emulator like in Kuja, and being able to see also the timeline of your protocol. Because we have IoT lab, but it's very difficult to develop such protocols without such an environment like Kuja.
Actually, you can also use RIOT on Kuja, because I mean Kuja is only partly Contiki dependent. So, and if we support several architectures that's also supported by Kuja, like the Sky mode, for example, You could actually just flash your or program your write application to Kuja as well. So it's actually possible to run it on Kuja, or you can use the other possibility that I told about. Is if you are not really interested in the hardware-dependent part of the code, just in the instruction level emulation, you can use this native port, where you can just virtually create your network. But it's probably difficult for Mac protocols. But there's someone who also implements Mac protocols for RIOT, and he started with Contiki, and he's using Kuja for this purpose.